My name is Kim Clark. I'm an integration architect working for IBM in the Hursley Labs in the UK. And I cover the IBM's integration portfolio, and I've been working in the integration space for maybe a couple of decades now. Over that time, I've been watching integration landscapes change, and one of the things I'm heavily focused on is describing that in what we call agile integration. And it sort of charts how integration landscapes have changed over the years from, as you see on the left-hand side of the chart here, a more sort of centralized enterprise service bus with a deep skilled team and a single runtime perhaps that's actually containing hundreds of integrations that eventually can begin to become a bottleneck. We've seen a move to more containerized integration where we decouple the individual integrations into smaller pieces, enabling them to be changed in a more agile fashion. And we're following what's going on in the application space, of course, as microservice architecture is doing exactly the same thing for applications. API management, of course, is allowing us to expose things across the environment and outside, potentially the enterprise as well, and so making the integrations we've created more accessible. So what we're really here to talk about is decentralization. And in fact, as we move from column 2 to column 3, what we see is an ownership change. The integrations that are now containerized can be owned by application teams. And so the application teams can start to look after those integrations, potentially even create those integrations themselves. So really we're giving teams more autonomy, allowing them to build, maintain and change their own integrations, and that's a good thing in the sense that it allows the teams to move at the pace that they need to move. But there's a downside as well, which is potentially a loss of governance across the environment. So this is kind of a utopian architecture. It's saying, you know, if we could build the perfect architecture, it would have each application owning its own integrations, only exposing sets of APIs and potentially emitting events to enable people to find the data or change the data inside that application domain. A more realistic view would be to say that there will be a mixture of existing centralized integrations. Many of those will continue to run, but they may even continue to run in a centralized enterprise service bus. There may be simply no reason to change that. Some of them could be broken out into containers, but still looked after and run by the central team. And then as we move further to the right-hand side, we're starting to see that decentralization happening. Some of the teams taking on their own integration, some of the integration perhaps happening in managed environments like an integration platform as a service. Looking at this just purely from the integration engine perspective, I mentioned that we'd be breaking these down into smaller pieces, making use of technologies like containerization. The aim with containerization is to be able to build much more lightweight components. That allows you to have a much greater agility in terms of the rapid changes and life cycle of creating integrations and deploying those integrations. You can scale containers up and down independently of one another and make really good use of the underlying capabilities in the cloud-native infrastructure. It's not particularly unusual to discover that an enterprise has hundreds of integrations. That's a fairly common number, especially for large institutions like banks and insurance companies. And so what we're saying here is, let's see if we can break that down into containers that are smaller in size, and that enables us to get this sort of agility that we desire. So, you know, each integration can be changed independently of the other ones. It can be handed to different teams to actually work on it. They can deploy it safely without affecting anything else. They can choose versions, for example, of the runtime that sits underneath it, and use the latest fix pack, for example, because it has a new feature or because it's got a security requirement or a security fix. So very, very powerful in terms of allowing this sort of decentralization of the integrations. And this is what we've been focused on for some years now in App Connect Enterprise. So some of you may know that as IBM Integration Bus, but version 11 of that product is App Connect Enterprise. And it's been written, to focus on being cloud native, to focus on running in containers in the way that you should run things in containers. And a lot of that comes down to changing the way that things are built and deployed. One of the things we could talk about here is what it means to build a topology for the product. So App Connect Enterprise, for example, in the past, you would have had to build your two HA pairs of servers, you'd have to set up an HA manager, you'd have had to build the load balancing across between the two, set up a DR site. Everything you're doing is very specific to the product and so on. In a container environment, you just specify declaratively what it is you're trying to achieve, and that could be stored effectively as code in a Git repository, for example. And then when you come to deploy your container, you're really just telling Kubernetes, so telling the orchestration environment what it is you want. I want so many replicas of this. I want them spread across these zones. I want you to balance the workload evenly. And the container orchestration platform gets on with doing that in a standardized way. And the beauty of this is that it's the same across all different capabilities. So whether you're standing up queues with IBM MQ, or whether you're standing up integrations with App Connect Enterprise, or indeed whether you're building API Connect, an API management system, you're using Kubernetes commands to achieve that, and you're using Kubernetes instructions in order to make that happen. So it's a operational consistency across different products, and things are working in a homogeneous way, in a standardized way. Another aspect to this is the automated pipeline, and this really moves us towards being able to provide a standard pipeline for anybody to use, so that the focus is really on just building the integration. You really can just lay down the binaries of App Connect Enterprise. You can lay down properties files to decide how you want it to be configured. The actual integration code, that's just laid down on the file system as well, and then you build an image from that and you hand it to Kubernetes, and Kubernetes will deploy that for you based on the specification we're talking about in the previous section. So that whole building of an automation pipeline is much more straightforward, and we can templatize much of that so that you can have standard images that you're building from, and even standard integrations. So maybe all you're changing in the end is just a mapping file to allow teams that aren't integration specialists to inherit all the good practices from the templates, and then just do the final piece of work on top to deploy something. So we can see the roles changing quite dramatically, and if you look on the left hand side, you can see that there's a lot of manual operation required towards the bottom of the stack, and there's a lot of work to set up and provision all the different pieces. And as you move gradually towards the top, you're still needing quite a lot of genuine product skill in order to be able to do the pieces, even when it comes to the artifact creation. What we're trying to do on the right hand side in this more cloud native approach is automate and templatize as much as possible. So even the building of a topology is done effectively by the container orchestration system. We're automating things like the build pipelines, we're automating the build of the topology itself, perhaps even adding templates for common styles of integration, so that the developer at the top no longer really needs to be an integration developer, he could be an application developer. And the people working on the looking after the environment, we class them as a site reliability engineer that's focused on automating the platform, rather than somebody that's having to do day-to-day manual operations to keep the site running. And it also makes it easier for example, you to provide a more managed service, whether that's a managed service that you look after internally, or whether it's something you buy from a vendor. But it's much clearer now what the expectation is in terms of what's managed and then what's worked on at the top level. Let's take a look at this from another angle. API management really has been focused on decentralization right from the start. The whole idea really is to create a capability that enables a team, initially it was integration teams, to be able to expose integrations as APIs, but it very quickly also got adopted by application teams. The idea being that they could expose their own APIs without having to turn to a specialist in integration or in gateways in order to expose their APIs. This has a significant effect as we start to look at more complex microservice landscapes. We see that the microservices are broken up into groups of microservices that are related to one another, and those are our decentralized sets, and those become applications, if you like, that are exposed through an API gateway, and anybody who wants to access the microservices and the data that's sitting within that application must come through, if you like, the front door of the API gateway. And so they become really critical in controlling the complexity, but also in terms of creating a consistency in the way that we're exposing APIs across the landscape. API management isn't just a gateway, of course. What it's bringing to the table is the API manager, and it's really the API manager that's enabling teams to come and define and administer their own APIs. Those get pushed onto the gateway and configured onto the gateway without you having to understand the gateway, so that's the decentralization aspect. And then also the portal, so being able to push APIs into a portal and allow developers that want to use your APIs to come to that portal, discover what APIs are there, subscribe to use those APIs. And so that automated onboarding process that you can set up is really critical to enabling the teams to be free from having to set up detailed contracts between each individual team. The gateways are designed to be multi-tenant in nature. They're designed with strong access controls to allow different teams to manage their own APIs. So the team implementing one application can come in and expose their own set of APIs on a shared gateway, but with complete control over just their APIs, and they can't touch anybody else's APIs in terms of definitions. We can, of course, have multiple gateways. We might be decentralizing our landscape somewhat across multiple clouds, and so we might have parts of our landscape sitting in different vendors of public cloud potentially. But the advantage of having a central API manager looking after those gateways is that we can start to get some of that control back. So yes, we have decentralized down into lots of different places. Yes, we have got teams working on different APIs at the same time, but they are all working through a centralized set of policies. So with our product API Connect, what we've enabled you to do is to have policies that are automatically pushed out to these gateways that enforce security capabilities, for example, to start to bring back some of that consistency across the different environments where the APIs are deployed. There's a big challenge here, not just in API management, but generally in the way that we're handling this decentralization in terms of the skill set that we previously had in the team that used to deploy and look after these environments, the team that knew, for example, the integration engine in great depth. How do we get that knowledge pushed out into the teams that need it? And so we see sort of different techniques here. Initially, we quite often see that team performing secondments out to those application teams to share the knowledge that they have and to understand the challenges that those teams are going through and start building things in terms of patterns for them and working out policies that will be able to be used by that team but can then potentially be shared by other teams. And then over time we move to models that we typically see in the microservices world, like guilds. And a guild is sort of a community of practice, if you like, around a specialism like integration, where they get together on a regular basis and discuss how things are being done in different teams. And so rather than a top-down kind of ivory tower way of controlling the way that things are done, the guild is aiming to bring those ideas out from the teams themselves and try and take lessons learned and then elevate those up to the enterprise. let's take a look then at the actual protocols and transport used to communicate between different parts of our architecture. And of course, there's a fairly ubiquitous use of HTTP for APIs and previously web services, but there's also still much use of messaging, traditional messaging, like our product IBM MQ. That's embedded in many organizations and running the core asynchronous transport. And we're also starting to see some new types of asynchronous communication. We'll come on and talk a little bit about Kafka in a moment. So what we see is a move from where we used to be, where, for example, IBM MQ used to have to be installed on the actual application runtimes themselves, and the application teams had to know how to look after that, running local MQ server, or indeed get a specialist in to assist them with looking after that. And we're moving to more of a remote communication with queue managers. So the queue managers would be remote, the applications would talk to them as a service and start to see them as a service. And that means that they can be deployed in a completely different way. We can start to package the messaging capability as a service, as something that's either easily deployed through containers or could even be deployed as a physical appliance. We have a physical MQ appliance now. And these enable very easy ways to create and administer queue managers rather than having to build them up in a way that was required deep specialisms. And that also allows us to set up communication across different clouds as well. So you can have MQ on cloud as a managed service. You can deploy MQ into containerized environments in a very straightforward fashion using the sort of operator net capability we have in OpenShift today. So there's lots of ways to deploy MQ in a very straightforward way, very portable way across different clouds, and allow the messaging to move between those clouds. So assured delivery across those clouds is really where MQ is bread and butter, is ensuring that when you send a message it gets to where it's going to go, regardless of what's in between in terms of the quality of the network or anything else. But we're also starting to see a move to the use of events. So a good example of that would be Kafka. Apache Kafka is an open source project, and we have a productionized version of that in IBM Event Streams, which is part of the Cloud Pak for integration. And Apache Kafka, instead of using queues where the messages are deleted as you read them from the queue, instead we have a log of events, which is an ongoing history of all the events that have ever happened. And there are many different patterns here. I've got a link to a presentation that goes into a lot more detail on the different patterns that are there. But a good one to relate to this concept of decentralization is the idea of projections. So you could have a back-end data store that you don't want to communicate with directly over APIs because perhaps it would put too much pressure on that system with the new uses that you've got. So trying to retrieve people's account balance on a regular basis through the day is something that system just simply wasn't designed for. So let's push the change events into an event log and then have your applications read from that event log and build a local data store of the information that you wanted from the back-end data store. You can now get to that data whenever you need it in a low latency fashion. You can store the data in a form that you want. It could be a different kind of data store altogether. You could be using a Redis database or a Mongo database. And what do we mean in terms of decentralization? Well, this is effectively saying that the team that's looking after the mobile application are now completely decentralized from the back-end data store. They now have their own version of that data. They're building that data store off of the event log, and they could rebuild it from the event log if they want to. They don't even have to go back to the data store for that, because the event log continues to be there. And so it allows them some significant autonomy in terms of how their application is working in a runtime sense. So it provides a way of decentralizing from a back-end data store and providing some qualities of service that we wouldn't be able to get in another way. Decentralization at first glance seems very much about people and how we decentralize ownership. But hopefully, as you've seen, it's also related to the architecture and, of course, the technology that sits underneath it. Plenty more information on Agile integration that you can go and explore at your leisure, and information, of course, on IBM's Cloud Pack for integration.